Hello everyone, I am Surjang Shupal. Today I am here to discuss about a new topic of data structure, and today's topic is queue. Like stack, queue is a linear data structure also. Queue maintains a FIFO policy. FIFO means first out, sorry, first in, first out. Next, how the queue looks like. First of all, we implement the queue in this video by using an array. So, if we take an array like that, so this is basically a queue. If we denotes, it is a front and it is a rear. Okay, let's change the color, that will be able to understand. This is rear. Let's suppose there are some values 10, 20, 30, 40, 50 and 60. What is front and what is rear? In stack there is one pointer top which points the topmost element. In queue there are two pointers, one is front, another is rear. Front points the front part of the queue and rear points the rear part of the queue. And initially both are in 0 position. That means both are in -1 position for an array. And in general case we take an is at 0 position. So in queue there are two operations. One is enqueue. Enqueue means data will be inserted in the queue. Another is dequeue. And dequeue means data will be deleted from the queue. Dequeue. One is enqueue and another is dequeue. So how the practical examples of the queue? If we think about a ticket counter, let's suppose this is a ticket counter. And there are 10 people are standing. 10, let's suppose 10. It may be n number of people are standing. And this is a first person, this is second person, this is third person, this is fourth person, this is fifth person, and this is sixth person. This person will come last position, last time, and this person will come for the first time, the first position. So, in our basic knowledge, that these people will got the ticket first, because he comes first, and he will got the ticket first. And these people will got the ticket last, because he comes last, so he got the ticket last. So queue maintains this policy, first in, first out. जो भी पहले आएगा वो उसको पहले टिकट मिल जाएगा, जो भी बाद में आएगा उसको बाद में टिकट मिलेगा. This person comes at the first position, so he get the ticket first, and this person comes the second time, so he get the ticket after this person, and so much. So this process is continue till the last person. So queue maintains this policy. The data which comes first will be dequeued from the queue first, and the data which come last will be deleted from the last from the queue. Okay. So there are two operations in queue. One other is, and first of is enqueue. In queue. How the data is inserted in the queue? First, think it graphically, then we move for the algorithm. As this is an array, this is an indexing. So its size is 6. So for the first time, front is equal to rear is equal to -1. We initialize front and rear. They are the pointers which will point the data. Front will point the first data and rear will point the next data. For the first time, we will update the front and rear both in the first position. Front is here and rear is here. And that suppose the incoming data is 10 and 10 will be here. For the next time, the rear will be updated and rear is updated. Now for the second data input, rear is here and data will be inserted at 20. Now again the rear will be increased by 1. Now rear is here and data will be entered at this position. For the fourth cases, rear is here and data will be inserted as 40, and for the fifth time rear is updated as rear plus 1 and data will be inserted, and for the sixth time rear will be here and the data will be inserted 60. So in this way a queue fills the data from front end to rear end. Now this is a graphical representation how the enqueue operation is performed. Now we are moving for the algorithm. What the algorithm says, like the last day when I talk about the stack data structure, I said that first of all we need to mention what we are taking. In this here we taking an array which named q of max. This is an array name. Front and rear are the pointers, and make front is equal to rear is equal to -1. Max is the size, maximum size of the array. Maximum size of the array. Okay. Now we move for the algorithm. Step 1. Here we use the array simultaneously with the algorithm. That will be helpful for us for understanding. Okay. For enqueue, first the algorithm will be start, and we check if rear is equal to max -1. Here the max is 6. For initial when there will be no data, both front is equal to rear is equal to -1. So and when the queue will be full, the front will be here and rear will be here. So for that case rear will be max -1 position, and we can write that these conditions is a overflow condition. And we will write it as a print with a printf statement, print overflow. Okay. If this condition fails, we will go for the next condition. Else if we will check if both front is equal to rear is equal to -1. That means the queue is empty. So for that case we will update front and rear both are 0 position. Front is equal to rear is equal to 0. For that case, where is the front and rear? Front and rear both are in the 0 position. Okay. and both front and rear is in now 0 position. If it is not in this case, and there is one last case, that is, let's suppose there are data 10, data 20, data 30. So where will be the rear will be there, rear pointed the data 30. For next input of data 40, we need to update the rear by 1, pointer r by 1. So we will put the rear is here, and we write here rear is equal to rear plus 1, and we will write it here in the else part. Okay, and finally the queue of rear will hold the data. Okay, there was one mistake, we forget to initialize the data. So here we initialize the data. What is data? Data is a user given variable name. Okay, so data will be input, and here the enqueue operation ends. So let's brief the enqueue operation. What is enqueue operation? Enqueue operation is a process by which the data will be inserted in the queue. And how this operation performs? Let's suppose this is a queue with size 6. For initial cases, both front and rear will be as -1. We will check that if the rear is in max -1 case, that means here max is 6, -1 means 5, then the queue is overflow, no data will be inserted in the queue. For that cases, then we check if the front and rear is -1, we will update both front and rear in the 0th position. Then we will update rear is equal to rear plus 1, and we will input the data queue of rear is equal to data, and we will input the data in the rear position. Here in this way the data will be inserted in the queue. This is rear, and this is the enqueue operation. Now we will move for the dequeue operation. Dequeue algorithm. Dequeue. By hearing this name dequeue, it will be easily understand that dequeue means deletion operation. That means we will delete the data from the queue. How that will be performed? Okay, I forgot one thing. In queue, the data will be always inserted from this end, like that way, and deleted from this end. That means the data will be deleted from this end and inserted from here, this way. Okay. Now go for the queue, dequeue operation. Okay. For dequeue, let's suppose this is a queue of size 6. 0, 1, 2, 3, 4, and 5. And data are here 10, 20, 30, 40, 50, and 60. Okay, here is front and here is rear. How the dequeue operation will be performed? First of all, for algo, we check front is equal to -1. Well, obviously this will be in if operation, and or front is greater than rear. For that case, the queue will be underflow. Second case, else আমরা যদি deleted, if we need to print the deleted value, then we will initialize the val and it will contain the queue of front, and front will be updated as front plus 1, and here the dequeue algorithm ends. What this means, if we take an instance, suppose here is 10, 20, 30, 40, 50, 60. Here is front and here is rear. We said that the data will be always removed from the front end because it is the basic condition of the queue. It maintains the FIFO policy. The data which will be entered first will be discarded from the first. So this data will be removed. First of all, this data will be held in the variable, and this value is printed that this is a deleted data, and front is updated front plus 1. Now front is updated, is here. Now front is here. This data will be deleted. Now same loop will be run. Front is updated here. So data will be deleted. So front, now these data will be deleted if the front is updated here, and in this way the deletion operation is performed in the queue. So here is the end of the queue data structure by using an array. But queue has several types. We will discuss the types of the queue in the next videos, but in this video we just tell the names of the different type of queues. What are the different types of queue? One is circular queue, another is D queue, that means double-ended queue. Another is priority queue, and last one is multiple queue. How the circular queue looks like? If we use indexing from 0, then it will be updated as 0, 1, 2, 3 and 4. What is the double-ended queue looks like? This is the double-ended queue. Any one of the end performs as a front and rear. This will be rear and this will be front. This is the double-ended queue's benefit, and this queue is very useful. We can double-ended queue is two types. One is input restricted, another is output restricted. As we do not learn about the linked list, so I am unable to see the priority queue, but I will show the multiple queue. This is look like some multiple queue, and this is 0, 1, 2, 3, 4, n minus 1, n minus 2, n minus 3. This is queue A, and this is QB. And here is the end of the today's video. In the next classes we will discuss about the circular queue and double-ended queue. Thank you everyone. If anyone have any doubts, he or she can ask me by WhatsApping me. This is my number. By using this, he or she can WhatsApp me and ask doubts. Thank you.